Hello everyone, I am Professor Rachna Mahule Sharma from MCA Department, PR Pote Patil College of Engineering and Management. We are studying the design and analysis of algorithms. In last lecture, we have studied about the procedures and functions. So in that we have learned that the biggest or complex problem can be divided into modules, and then we are preparing to solve that modules one by one, and then we are going to combine the results of that to get a particular result there, to get a particular solution there. Now today we are going to learn about the iterative algorithm design issues. In that, we are going to learn about different objectives. Here, we are going to learn about the loops and the efficiency of your program, how we are going to prove our program is better or our algorithm is better. What are the factors which are affecting that algorithm? So that we are going to learn in this particular lecture. So let's start with the objectives of this chapter. In that, we are going to learn about the correct use of loops in program. Of course, why we are using loop, how loop constructs are constructed, that we are going to learn in this. After that, we are going to learn about the efficiency of algorithm. Of course, whenever we have to create an algorithm or whenever we want to implement that algorithm, we will see that algorithm is better or not. If it is good, then we are going to implement that algorithm in our programming language. By using some programming language, we are going to we are going to implement that in a program. After that, we are going for the compare algorithms. That is nothing but the complexity of your algorithm. That is, here we have the ordered notation. In that, we are going to learn about the complexity. We are going to compare the algorithms, then we are going to find out the complexities of that algorithm. Then we are going to measure the problem size as a measure. That is what here the justification for the use of problem size as a measure. Of course, problem size is very important there. And after that, we are going to learn about the trade-offs of the algorithm design. That is what here we have some objectives of learning this chapter. So let's start. Here in this lecture, we are going to complete the correct use of the loops and loops in program. And secondly, we are going to complete the factors that affect the efficiency of the program. So let's start with the first point, that is the correct use of loop in a program. So let's start with this, how the loops are used in our program. We are knowing that in our program, in our algorithms, we are using different conditions. That conditions will be having the true or false part. That is what if we are using. We are using the if construct, that is the conditional construct. In that, if the condition is true, we are going to execute the true statements there. The statements which are come under the module, that is the true condition. And if that condition is false, we are going to execute the statements under the false situation, false condition. So that is what if we are using, but it is happen only one time. Most of the time we need to repeat that statements, means we need the iterations of that statement. At that time we are using that iterative loops here. We have to use the loop construct here. Whenever we are going to use that loop construct, we have to design it. And to design that loop constructs, we have to concentrate on the three aspects of that. We will see one by one what are that three aspects. So here we have listed that aspects. First is the initial condition that need to be true before loop begin execution. Now of course we have to start somewhere. So that is what the initial condition. We have to put one initial condition and from that our loop is going to be executed. Then after that we have to put the invariant relation that must hold before, during and after each iteration of the loop. Here that is what the actual iterative logic. Here we are going to put what are the conditions that particular loop will be iterated, how many times, where it will begin, is it true or false. We are going to find out each and every, we are going to put that conditions in this, that is invariant relations. For example, if we are using for loop, in that we are going to initialize the I. Suppose one variable we are using in that for loop and that variable is I. So here I should be initialized. Then secondly, I should go for the condition, and after that I should go for the increment. So here we are using the relation between that I. First the I should be initialized, then condition will be checked, and then there will be the iteration, that is the incrementation or decrementation. And within that we are having multiple statements. If condition is true, that is going for the execution. Then after that there will be the incrementation, again the condition will be checked. That is what, how they are related to each other. That is what the iterative logic which is there, that we have to put it in that loop construct, and that is nothing but the second aspect, that is invariant relation, that should be hold there. Then last one is the condition under which the loop must terminate. Now of course when we are starting the loop, it should be terminated. So of course if the condition is true, the loop will be executed, and if the condition goes false, at that time the loop should be terminated there. The control will go to the next statement after the loop. So that is what the last condition, and all these three are important there. So we'll see one by one how we are going to put that initial condition, how we are putting that logic, that is invariant relationship between the variables here, and after that we will see what are the condition to terminate. Okay, so that is, first we will see the initial condition here, how initialization is done in the loop construct. So let's start with this. So here we have some design processes. In that, the first process is to establish the initial condition. So here, what is meant by initial condition? That initial condition means here, that is what, here we have to set the loop control variables to some values. Here we have to put some variables, we have to choose some variables, and we have to put some values for that variables. And here it is the smallest instance of your problem in question. That is what the from very first point we are starting. So that start condition is having some initial values, and that is called as to establish initial condition. That is called as initial condition. Now here we are going to take one example. Suppose you are having one array and you want to make summation of each element of that array. For example, that array is suppose having the numbers, 10 numbers are there, 1 to 10, and we have to we have to get a summation of that. For that, what we are going to do? We have to choose some variables here. To complete that, to get the solution of that summation, we have to put some variables. So initially what we are going to put, here we are going to take a variable, that is I. That I is the loop control variable which is also used for the array index. Of course, here we will have the array. Suppose that array is having name A. So here we have A of 0. That A of 0 is first element of your array. A of 1 will be the second element of your array, and we will go up to the 10th element there. So here I is used for the iteration purpose. We are going to initialize it, we are going to increment it. The second variable here we are using is the S. That S is the current value of sum. So whatever summation we are going to check or summation we are going to put, that summation will be assigned to the variable s here. So it will hold the value of summation of your program in your program. So that is what the second variable. So what is the initial condition? So here we have the smallest problem in which the sum of zero number of element. Of course, whenever we are talking about the sum, initially we don't have any element. The at I is equal to 0, there are no numbers. So of course summation will be 0 here. So we have to put the number is not there. So we are going to put number as 0, that is I is equal to 0. We have the very first iteration there. So we are putting I is equal to 0. And the secondly we are having s is equal to 0. We don't have the summation of that number, any number there. So that is what the smallest condition, that is called as initial condition here, from where we are going to start. That is the first step of your algorithm or your program. So that is the first program, that design process to establish the initial condition. Now we are going to take the second condition here to find the iterative construct. Of course, we have to choose the invariant relationship here. How your program will execute it, how it will be iterated, how it will go for the next steps. So that is what the iterative constructs. So here in iterative construct, what we are actually going to do, here we are going to try to extend the smallest problem to the next smallest. Of course, here we have the initial condition, that is I is equal to 0 and s is equal to 0. We have to go for the next value, that is I is equal to 1. We have to move in the array to the next element. So that is what we are going to the next solution, to the next problem here. So here we are putting that case will be n is equal to 1. Means here we have number of elements that is equal to 1 there. 0 and 1. Now it is 1. Means here we can have the summation. So here in that case we are having the a is equal to I. A of I, that is A is your array and I is now 1. Initially the I is A of 0, that is the first element. And here we are having A of I, that is what here we have A of 1 here. So we are going to put I is that 1 is assigned to I because number of elements is 1. Then second is S, that s is assigned the value, that is a of 1. Whatever value will be there in a of 1, that will be assigned to the summation. Now we are moving next and next, that and we are getting that the values, we are always going to increment the value of I and we are going to take a summation of that. So incrementation is written like I is assigned the value, that is I plus 1. Then the initial condition is what? Here we have the problem, that is n is equal to 1. Then we will go next, n is equal to 2, n is equal to 3, n is equal to 4. So we have to increase that value. So here we are going to increase the value of I, that is I plus 1. Always in each iteration we are going to take the value of I is incremented by 1. So here we are getting the value of I, that is I plus 1. And after that the summation is the cumulative summation. Always we are taking the previous summation and the actual value of I here. Whatever number is present at that particular index, we are going to add it into the summation. And we are getting the new summation here, that is S. So that is what here we are talking about the iteration. So we are moving in the next and next conditions, next and next value, and then we are taking the summations here. So that is what here we are using to find the iterative construct. We are constructing the iterations. Now here that program will be, by using these two, we are having the program. So here the program is, here we are using n, the condition that n greater than 0. That is actually what we are checking. That is initially. We have to check the condition. If n is greater than 0, then and only then we are going to execute that program. That is the beginning of your iteration. Then here we have the initialization, that is I is equal to 0 and s is equal to 0. Then here we are putting the condition I is less than n. How many times your iteration should be there, how many times your program should be iterated, your statement should be iterated, your summation should be calculated, that is given in I less than n. Suppose I is 1 and n is equal to 5. So at that time the condition is true, and then we are going to execute these statements. So if the condition is true, we are going to execute that. If the condition is false, we have to move next to the loop. We have to move to the next statement of the loop there. So that is what here we are having the condition. We have to put that statements inside one condition, and that condition is checked by the loop construct. That is what we are using in this program is while I is less than n. Condition is true, that I and s will be calculated, and after that it will be end by using the end while statement. So that is what in this program. But what happen if we are knowing the fixed values of the that terminations? So that is, now we are going to learn about the termination of your that construct, that loop construct. So lastly, we are having the third point here, the design process of your algorithm, that is the loop construct here. So last point is the loop termination. We have to terminate the loop. For that we are choosing generally the structured loop construct, and that is for. That construct is used when we are knowing the fixed number of iterations. How many times your data should be iterated, if we are knowing that, at that time we are using the for constructs. For example, here we are choosing the for. Here the for is starting from 1 and it will end up to 20. If we want, suppose here we are taking the example, we want to print the numbers from 1 to 20. At that time generally we are using for. We are initializing I is equal to 1. It will go for I less than or equal to 20, and after that we will increment I plus plus. So, and after that in the block of statement, in the body of that for loop, we are going to write print the particular number there, and after that we will exit from that loop. After 20th iteration we are going to exit from that loop. So here we are knowing, if we are knowing the proper constant, proper values, when to begin and when to end, that at that time we are using the for constructs here. Suppose, and it is not necessary to have a constants. We have 1 and 20, 1 and 50. Not like that. Here we can use some variables also, but that variable should be initialized before they have use. So for example, here we are using that construct, that is for I is m to n. Here the variables I have given m to n, but the values should be defined previous to that particular for loop. So here we are using that m and n, but here we are assuming that the value of m and n are known. For example, m is equal to 5 and n is equal to 20. So it will go from m to that 5 to 20 there. So that is what here when we are using the for constructs. Most of the time we are using two conditions also. Here we have the example for that. Here we are using some false conditions to exit the loop. So here we have the for loop, that while loop. That while loop is having two conditions. If x is greater than 0, for example 1, and x is less than 10. For example, 9. Okay, so it will run the statements inside it when x is equal to 1, x is greater than 0, that is from 1 and up to 9 there. Means 1 to 9 it will be executed, and if that condition is false, for example here we have x value is minus, so it will exit the loop, it will not execute any statement there. And if the value of x is 11, at that time it will also not execute that loop, so iteration will stop there. So that is what here we have the conditions for termination. So that is what here we have three design construct. First is the initial condition, second is the invariant relationship, and third one is the termination of the loop. Now we will see here the efficiency of algorithm. Now what is that efficiency of algorithm? Most of the time when we are going to execute the algorithm, that algorithm use resources in your system. That resources are using your CPU time and the internal memory. So here we need the algorithm that uses minimum resources here. That is, here the algorithm should use the minimum CPU time. That algorithm should be fast and it should use minimum memory there. So actually the efficiency of that algorithm is depends on time and space. So that is what the actual efficiency from which we are calculating the efficiency of your algorithm. There are some factors which are affecting on the efficiency of the algorithm, and that are here the factors are: the first is the removing redundant computations outside the loop. The second is here the referencing of array element. After that we have the insufficiency due to the late termination, and then here we have the early detection of desired output condition. Now here generally the most of the programmer uses multiple lines, multiple calculations are there. Referencing is problematic there. So that is what they are using, and that affect on your algorithm, on your program. Most of the time we are choosing wrong conditions there for termination, and that will also affect your algorithm, that will also affect your program. So that is what these two: insufficiency due to late termination, the actual result is okay, you are getting that result before very early, and you are going for the executing the loop again and again. That is what here late termination, you have to terminate that algorithm previously, but here you are executing continuously that algorithm. That is what inefficiency, that is what the choosing wrong conditions for that. So that too are depend on the conditions. Now here we have the first two we are going to learn in detail, that is by using the example we are going to learn this two. First is removing redundant computations outside the loop. Now here most of the programmer uses most of the calculation inside the loop, and that will take more and more time. If we can calculate it once, then why to go for the iterations there? So that is what removing the redundant computation. Now we will see that with the help of example. Now see here, we are having that example. In this example we have used one variable, that is x is equal to 0. Now it will go, here we are using the for, that for I is equal to 1 to n. Here we have the I is going from 1 up to nth element. For example 10, 20, 30, whatever it may be. So it will go from 1 to n. Here it will have the body of that for statement. In that it is calculating some values. Here the x is calculated. X is equal to x plus 0.01. So it is calculating the x value. X is initially 0 and now it will have the value that is x plus that 0.01. Now it will go for the calculation for y. In that y, we are having the values that is a multiplied by a multiplied by a plus c. After that, here it will calculate b, that x and x. Of course, that x will go inside that loop, and here it is calculating b multiplied by x. So here x value is okay, it is modified here, but the a, c and b values are not modified in the loop. So we can use here that particular values, we can calculate that particular values outside the loop. Why we are using that values, why we are calculating that values in for loop up to nth iteration. We are multiplying that values up to nth iteration, from first iteration to the last iteration. So here we can remove it. How we are going to remove it? We can remove it by declaring the two new constants. Here we are using two new constant, and that two new constant are A3C and B2. A3C is nothing but here we are calculating multiple times, we are multiplying that particular values in a loop, and here we are moving it outside the loop. So that is what here A3C is, that is the value of a multiplied by a plus c. Means only one time we are going to calculate that value. The secondly b2, and here we are using b multiplied by b. Means multiplication operations what we are repeating in the previous example, that is now removed in this. Now here we are going for 1 to n, and here we are going to calculate x as it is, that is x plus 0.01, and now we are going to calculate y, but here we are using the direct value for A3C, and here we are using the direct value of B2, what we have calculated initially out of the loop. So here we have removed the multiple computations in that loop here. So we have, in best practices, we have to remove that redundancies, so that we the execution time required for that will be less, and the space is required for that is again less. So that is what here we have to remove the redundancies here. The next we will talk about the referencing of array element. Now we are knowing that the array elements are referenced by using some any particular variable. If you want to go for a particular element in the array, we have to move from base of the array. We have to calculate that value from base to the particular location of that number. So that is what multiple calculations are there to reach up to that position. We can take it directly, but here internally it calculates the position of that particular number, and then it will assign, or then it will retrieve that value from that array. So when we are referencing the array element, that is what the problem. Multiple times we are referencing, and if that reference you are using in the iteration, multiple times it has to calculate the position of that particular element. Now for that, here we have one example, that is these two are the versions of the same algorithm, and that algorithm is to find the maximum number of its position in an array of numbers. One array is given, the number array is given, and in that we are going to find out the maximum value in that particular array. So here we have two versions of that algorithm. The first version we will see. Now here in first algorithm, what is given? In first algorithm we are going for initialization, that position is 0. We don't know what is the maximum number there. So we are initializing it with the 0 number. We are starting with the 0. Then here we are going for the loop. So of course here we have I is less than n number of elements will be there here. Then here we are going to check the condition a of I is greater than a of p. Means always we are choosing one particular variable, one ith position, and we are going to check that ith position with a proper element. So if it is maximum, it will be moved there. So here by always we are going to reference that particular element. So that is what present here. We are multiple times we are referencing that element. Then after that, the last step is what we are, after getting the maximum number of max element, we are going to assign it to the max. So that is what multiple times we are going to the array, we are calculating the positions of that array, and then we are checking it is max or not. Now in second version, what we are using, here we are putting if the max element we got, that max element will be assigned to the max variable here. Then we are moving inside the for loop, and in that we are going to check that particular a of I, that is index of that I, whatever I position is there, it will be checked with the max. If it is the single variable what we are checking, and here we are having the position of actual position of the array. So that is what whenever we are using that second version, it is better. We don't need to go for a particular array there multiple times. We are choosing only one variable there. We are comparing one variable there, and we are getting the answers there. So that is what these are the factors which affect on the efficiency of your algorithm. So that is what here we have to choose a proper factors, proper conditions, and proper values here for references, or here we have to choose a proper statements or loop construct to get a particular for getting a good algorithm here. So we have to always check the efficiency of that algorithm, and we can improve our algorithm by using that particular factors, by using the proper factors there. So that is what here we have talked about the use of loop and efficiency of the algorithm. What factors are affecting on the efficiency of your algorithm. So that is for today. In next lecture, we are going to talk about different factors which are again affecting on your algorithms. So that is for today. Thank you.